The project aims to address the IMO, this is the International Maritime Organization, ship evacuation requirements that they've specified recently in one of the MSC meetings. And these are to establish appropriate response time distributions for passenger ships, establish a database of assembly time data suitable for the validation of ship-based evacuation models, and propose additional benchmark scenarios that can be used in evacuation certification analysis. So again, this is not a million miles away from what we heard in the keynote address. The International Maritime Organization wants to have a data set of realistic response time data that can be used in evacuation simulation analysis. And so we're collecting that. They want to have a data set, a reliable data set for validation, so that you know where people start and how long it takes them to get to the assembly station, the routes that they've taken and so on, to construct a suitable database where we can validate evacuation models. And the third thing it wants to do is to establish an improved set of benchmark scenarios that are used to assess ship design for evacuation. Currently we have a set of 4 scenarios, 2 so-called day scenarios and 2 so-called night scenarios. What we're going to be doing in this project is we're extending that to include situations where you have a fire on board the ship and when the ship has an adverse angle of heel. So these are going to be new scenarios we're adding to this. Now, to address these requirements, we're going to do 6 full-scale ship evacuations. And the unique thing about these ship evacuations is the ships are not tied up alongside. The ships are going to be at sea. And we're going to evacuate the ships at sea. Okay, so we're doing 6 of these unique trials. So far, we've done the first 2, and they're the 2 trials I'm going to talk about. We're looking at 3 different types of vessels. We're looking at large ferries. We're looking at large ferries with cabins. And we're looking at cruise ships. And the cruise ships that we're looking at will have something like 3,600 passengers. So hopefully at the next PED conference I can talk about the experience we had in evacuating 3,600 passengers at sea. The first 2 trials have been successfully completed on the Coal Line ship, Superspeed 1, and this is a RoPax passenger vessel. The ship was sailing between Norway and Denmark, and we undertook 2 evacuations on 2 separate days with 2 separate groups of passengers. On the first day, the first trial we did, it involved 1,431 passengers, and on the second trial it involved 1,349 passengers. Now, what I'm going to be talking about in this presentation is some of the, I think, unique methods we've used to collect the data sets to do the analysis. Give you some idea of the ship. The passengers are spread over 3 decks on the ship, deck 7, 8 and 9, and the decks have a mixture of space. It includes airline seating, just like you get on an aircraft. It includes large retail areas, bar areas, restaurants, cafeterias, general seating areas and general circulation area. So it's like a floating shopping mall in many respects. That's the picture of the vessel. These are the 3 decks that are populated with passengers. And on board the ship, what's the normal practice is you have an assembly phase where the alarm goes off and all the passengers have to go to their assigned assembly stations. And then from the assembly stations, they go to the lifeboats. Now, we only ran the experiment to get everyone into the assembly stations, not to get them into the lifeboats. That's actually quite dangerous, and we didn't get ethical approval, and the companies would never allow us to do that. So the best we could do is the assembly process, getting passengers to the assembly spaces. This vessel has got 4 assembly stations, 3 on deck 7, there's 3 on this deck, there are 2 outside, and there's 1 inside, and there's 1 on deck 8, which is also inside on this location here. So there are 4 assembly stations on this particular vessel. Okay, so how did we collect the data? Well, we used 3 methods to collect the data. The first was a questionnaire. We developed a questionnaire, and the questionnaire was in 3 different languages. It was in English, German and Norwegian. And the questionnaire was designed to ask very specific behavioural questions, why people were doing what they were doing. We also used video footage. We positioned 30 digital video cams throughout the vessel, and the purpose of those cameras was to collect response time data. How long did it take from the sounding of the alarm for the passengers to start to evacuate? And is an example of that. The third thing we did, which is what I want to talk about mainly, is this unique thing that we did, is we used infrared technology to track the passengers. And essentially, you have 2 pieces of equipment. One is the beacon, which is this thing here. You can see it's quite small. It's an infrared beacon. And the other is a tag. It's an infrared tag. And the passengers wear the infrared tag like that. So it's got to be an announced drill. They have to wear this thing. And I want to talk a little bit about how this technology works, because it's really quite exciting. It's given us some very good results. So how do we track people? I should say we looked at using video. Video was no good in this place because there wasn't enough headroom. Most of the video tracking systems had bird's eye view, and we just simply didn't have enough space to mount bird's eye view cameras. So we looked at other ways of tracking passengers, and there were 2 ways: RFID, which is what most people tend to use, and the second was a new technique which we've helped develop called infrared. Now what both of these techniques do, RFID and infrared, is the device sets up a field, which we call a gate, and as the passengers move through the field, they're wearing a device which is activated by the field and somehow records or sends a message that I've passed through that field at this particular time.